Hey, good morning. This is Paul Yaginuma, and this is my presentation for my final project for CIS 498. I'm recording this just in case I have internet issues, so hopefully we won't need it. But with that said, jumping right in, what I made this term was a three-tier application called Personal Trainer, and essentially the application is an alternative to personal training. It offers users the ability to put in their individual information, age, access to equipment, limitations, things like that, and it will spit out customized exercises that are suited to your needs. Um, what kind of drew me to this was personal training is expensive on one end, and then exercise generating applications or websites that exist right now aren't so tailored. They're usually just retrieval databases that you can kind of filter through for equipment or age or whatever it may be. And I wanted something that was more accommodating for user specific needs, whether it's unorthodox equipment, like you're stuck in a hotel room and you only have a towel and a backpack, but you want to get some stretching or exercising in, or you have a very specific injury that needs to be worked around. Um, the databases for the existing applications are only so big, and a lot of them don't account for things like that. So I want to use the power of LLMs to try to come up with unique exercises for each user. So generally how it works, you just put in your user information after you make an account. You put in what equipment you have. You put in your injuries. You put in what area you want to focus on in your body for your workout. And then you hit generate and it spits out some workouts for you. Um, and so if you have a moment, I would encourage you to go ahead and pause it and try it out. The URL is right here. It's just personal-trainer-final.web.app. And you can either create a new account, just make up an email. It doesn't actually verify it for the time being. Just remember the password because you'll have to then immediately sign in after you create an account. Or if you prefer, just use an existing account. There's a couple of emails on the side. And the password for both is just 123456. And it's pre-populated with some user information so you can kind of see how it works, maybe generate some exercises. So perhaps while you're doing that, I'll just walk through the application flow that a user will see. So first you're presented with the login page, and that has the functionality of either sign in if you already have an account, or you can click sign up, and that changes the page a little bit to a sign up page where you can create an account. Once you create an account, it'll pop you back over to the sign in page where you sign in, where you're presented with this first screen here. So it'll have your name and your email, a logout button, and then a bunch of fields where you can enter information, specifically equipment, age, injuries, what area you want to focus your exercise on, and your level of overall fitness. And I kind of pick those just based on what factors you would need to consider when coming up with an exercise routine, things you might discuss with a personal trainer. Then once you hit generate exercises, it'll think for roughly 20 seconds, and that's just however long it takes for the backend to call the GPT OpenAI API, get a response, kind of format the response, and spit it back over to the front end. So once you get some exercises generated, right now we're going with 3 exercises per click. So you get the exercises, they'll be kind of stacked vertically, and you can scroll through. It'll tell you what equipment is needed, what the area of focus is, the instructions for the exercise, and then reps and sets. Then you have the option to save. Each exercise at the bottom of the exercise will have a save button, and that will save it to your account so that when you log back in, those will populate under your saved exercises. So if anything kind of answers the mail for your what you're looking for, they'll be saved to your account in the future. And then you can always go back through. You can click the little X next to whatever item on the list. That'll delete it from both the HTML list and the database. So you can always edit your information as your needs change. And then this is just a quick look. If you stack these boxes kind of vertically, it ends up being a kind of a vertical scroll website. I had initially planned kind of just wire diagram wise to have exercises kind of horizontally and then stacking the saved exercises versus generated exercises vertically, but both because of ease of creation, I wasn't too familiar with CSS. It was just easier to stack things vertically and append them, and then I realized that it's actually ends up working better for things like accessing this on phones since your screen is portrait orientation anyway. So having things stacked horizontally doesn't fit the screen as well as just having a big vertical scroll application. So it ended up working out. turning to a few key design decisions. The main one, like I mentioned earlier, was kind of the database versus using an LLM decision. Using a database kind of allows you to know exactly what's in there. You have a certain number of pre-populated exercises, and all of the information for all those exercises is pre-populated, so you'll probably have a column for equipment required, a column for suitable for this level of fitness, suitable for this age range, things like that. And then essentially you're just running a filter script. So somebody puts in their information and it filters down all the exercises that match their needs. They can click through by probably what area of the body or what muscles that exercise focuses on. So a perfectly fine solution, just not as tailored as I was looking for. I couldn't find any data sets that had a lot of detail for injuries or limitations, or data sets that used, like I said, unorthodox exercise equipment, because we don't always have access to even exercise bands. We might have, I don't know, a golf club and a bath towel, and you want to get some stretching on your back in, but you don't want to go down the YouTube rabbit hole. So then the alternative to that is using LLMs. So that would create essentially endlessly customizable exercises based on exactly what you have and exactly your needs and limitations. So we kind of landed on that as the more user-friendly solution that has more value added than kind of filtering through a database. The next big decision after we had landed on LLMs was whether we should have user accounts or no user accounts. I had never made an application, I guess full stop, but including an application to create user accounts, so I didn't really have a great sense of how involved that was. But just thinking through the usability and user friendliness of the application, if you have an account, you can save your basic information. So you can enter your age, which doesn't change frequently. You can enter your fitness level, which doesn't change frequently. And then if you want to change your equipment, it's easy to do so. But this way, you don't have to re-enter everything every single time. The other big benefit is the ability to save workouts. So if you come across an exercise that you really like, you don't have to copy and paste it out of ChatGPT, or you don't have to write it down or just write a note in your phone. It's just always in your saved account. It'll populate every time you log in. And that's both just more user friendly and kind of keeps bringing people back to the website so they can redo the workouts that they like. And then once we had kind of settled on the LLM and having user accounts, then it was down to the meat of how am I actually going to build this thing. I had had some basic experience trying to start up a relational database in AWS in the database course, but I had never used cloud tools besides that. So what I landed on was called Google Firebase, which is kind of a smaller, more user-friendly set of tools within the Google Cloud ecosystem. They have kind of turnkey tools for authentication, which is their user account and management tool. They have something called Firestore database, which is a NoSQL database. Um, and so essentially, after a lot of Googling and tutorials, I learned you can just drop in some config code, and that kind of talks to the backend API for their servers. So their authentication tool handles and stores user accounts and passwords, for example. Their database is pretty user friendly. It just creates the documents and then stores the user information there. I landed on the NoSQL database just because we're not storing anything complex. There's not a lot of relational information here. Each user just has one document where their information is stored, and then under that user's document, there's a sub-collection is what Firestore calls it, and that's just essentially another folder of documents, and each exercise that a user saved is given its own document. Um, and then kind of other miscellaneous decisions were what coding languages to use, where to write certain functions. Would I try to do everything in Python and kind of force that onto JavaScript by using a different framework? I looked into things like React or Angular, but wasn't familiar with them, so I decided to kind of do as bare bones and easy to learn as possible. So I didn't use things like frameworks. I just used the base HTML and JavaScript to give the HTML functionality, CSS to style it, and then for the backend, I was familiar with Python, so I did all of the kind of backend business logic in Python, and that's talking to the GPT API, getting the output, formatting the output into variables for each exercise, and then spitting that back out to JavaScript to display on the front end. Um, there was a decision on which LLM provider to use. I had used ChatGPT and their API before, so that was a kind of a no-brainer for me. It's good enough, available, and I had used it before. And then for how to format the output, the big question is LLMs don't spit out consistent responses every single time. So I did it kind of in two ways. In my prompt, I tell it to use specific keywords and kind of a specific formatting. So exercise name one, colon, and then the name, and then exercise equipment required one, and then the equipment required for the first exercise. And then I ended up using just those keywords to split the answer on so that Python could have the different variables for each exercise and then save those to variables and then pop those back over to JavaScript. But we'll get into that a little bit later. So general success criteria, since this isn't a tool that will be used for an existing business, it's kind of a new application. The overall functional success criteria is that it works for the objectives that we set out. So users can input their information, generate exercises that are tailored to them specifically, and save those exercises to their accounts. The technical components just kind of break down that functionality into the subcomponents. So there's the login, there's the authentication user accounts subcomponent. Users need to be able to make accounts and log in and log out. They need to be able to save and edit their user data, the age, the fitness level, things like that. They need to be able to generate exercises. That's the back end where it talks to the LLM. And then they need to be able to save and delete the exercises. They also need to be able to populate all of their information and their saved exercises on login, so that when you log in, it's pulling all of your information from the database, it's populating those exercises. And then finally, the application hosting. It needs to be available at a public URL and up so that the users can actually use it. So this is kind of the wire diagram of the architecture. It's just arrows point to kind of the flow of when the user logs in, they go to the login page that talks to the backend Firebase authentication, which talks to the authentication server. It validates the user, and then once you're logged in, it spits you back out to the main application page. That's where they would enter their information. They would add all the information that gets stored to the user's document in the Firestore database. When they click generate exercise, that's kind of when the backend fires up. The user information stored as variables in JavaScript are then sent to Python via a fetch request, using post. So what I learned is that that essentially sends over a JSON file full of information. Something happens with that JSON file on the back end with those variables, and then a JSON file is returned. So what happens on the back end is the Python function takes in the user information, it fills out a prompt for GPT using that user information, and we'll get to that later, but essentially generate exercises for a blank age person that has blank level of fitness. It spits that into the ChatGPT API, which then generates a response, and again, it has those keywords in the output. That comes back to Python, which then formats the response by splitting it on those keywords. So you'll have, at the end of the formatting, name a dictionary, key value pairs, where it says name one and the name of the first exercise, equipment required one, and the equipment required for the first exercise, and so on. And then that gets sent back to the front end where it is displayed under generated exercises, and then it's up to the user to click save for whatever exercises they want to save under each one. When they hit save, that exercise is then stored in the Firestore database as a document, in the subcollection under their user document. So that was a lot. I won't go through each of the code files, but this kind of breaks down the functionality of the code files into three largely separate functions. So there's the login code, where there's the index.html, that's the first page you see that has the login functionality. Script.js just holds the code for showing or not showing the sign up or the sign in page. And then Firebase auth.javascript holds all the functions for signing in and logging in. It talks to the authentication tool. And the reason kind of the code is structured the way it is that it is kind of a hodgepodge of different tutorials I broke it down into function. So I kind of watched a tutorial that did nothing but create accounts using Firebase authentication, and they had it structured this way. So I did some tutorials and tweaked it using the same structure. For the homepage, for adding buttons, for adding event listeners, things like that, I watched different tutorials and kind of kept that tutorial structure the same. Same thing for the fetch functions in the back end. I watched how to use fetch, how to use post, how to talk between JavaScript and Python, and kept those kind of file conventions and namings the same. So then moving on, there's the HTML, there's the JavaScript, there's the CSS, then there's the Python files, which end up getting hosted in Google Cloud Functions. Um, so when JavaScript talks to the backend, it is talking to a URL that was created by Google Cloud Functions, and we'll get into that a bit more later. Then there's just the styling, an image that you saw on the login page, just of the shoes and the jump ropes, and then a couple just text files that I used when I was testing so that I didn't actually have to call the API every time there was a bug in my formatting or my fetch request. So jumping kind of into the cloud tools that I used for user accounts, it's a tool called Firebase Authentication, and you can see that these tools kind of live under the overall project, Personal Trainer or Final at the top here. Authentication exists as a tab under that project, and this is where you can manage and see data for the user account. So you can see the email that the person used to create the account. You can see when it was created, when they signed in, and then most importantly, their unique user ID. So each user gets a unique user ID, and that's how you can kind of search through them or discriminate users. And where that comes into play again is the way we have it set up is that each user then in the database, a document is created for that user, and the document ID is this user ID. So that's how we link the user to their own document, and then all of their saved exercises live under that document. So then that brings us to the database. So you can see that there's an initial umbrella collection called users here, and then each user gets a distinct user ID, like we said. And then within that document is where their user information lives. So when you type in all your information here, age 55, for example, it lives as a key value pair in this main user document. And then the way the Firebase UI works is saved exercises is here under what they call a sub collection. So then when we get when we click on saved exercises, essentially it's a folder, and in that folder live a bunch of other documents, each one being an exercise. And we see that for each exercise, they're also stored as key value pairs. So there'll be the exercise name stored as a value, the equipment needed, the area of focus, and those are all kind of variables stored as key value pairs in a dictionary. And that's what we pull from, save it to a variable, and then populate the main homepage with. So app hosting, this is something that was new to me as well, but it ended up actually being much simpler than I was expecting. I guess I didn't really know what to expect, but at the end of the day, once I had everything working locally, I just dumped everything into a folder called public, pointed the kind of hosting tool to where that folder lived, and then used the terminal to upload all the documents I guess to log into Firebase first and then upload all the documents, and it just hosts those files on a cloud server somewhere versus hosting it locally. And then this is also what gives you an actual URL that's publicly accessible to get to. So that personal trainer final.web.app. And my understanding is web.app is just a URL that Firebase owns to host their apps. So I think any Firebase application has a web.app URL. This is just kind of the usage GUI for the OpenAI API. It just tells you how many calls are being made, how much you've spent this month or this session, whatever you're looking for, and then what type of model you've used. So for another course, I made a bunch of images for an image classifier, and then down here, I believe in the green, is all the calls that I've made to the LLM, in this case, GPT-4o. So this is kind of a look at Google Cloud Functions. So the way it works, I've learned, is there's just an inline editor. So essentially, I wrote the Python function in my IDE, which I used PyCharm just because I was familiar with it. I copied and pasted that into the inline editor. Um, and then I had to add the requirements, which was a bit tricky. I had to actually figure out what version numbers I needed. So I figured out how to look up what Python version I had for in PyCharm, and then which version of the packages and the libraries I needed that would talk to that version. And then once I figured that out, you can upload it, and then it gives you, as I mentioned before, the URL. So this is a public-facing URL that the fetch function can then send its information to, in this case the user data, and then this will return another JSON dictionary of the exercise key value pairs. So the quick overview of how this works, there's one function that's the main function that points to. So this function handles taking in the JSON from the JavaScript. You can kind of see here it creates variables by breaking out the JSON data for the user information, and then it dumps those variables into other functions. So there's a generate exercises Python function that lives below this that we'll look at next, that takes in all the user data, generates the prompt, gets the output. Then there's a format GPT output function that takes in the GPT output and formats it back into kind of key value pairs for each of those exercises. So this is the prompt generation. Like I said, it just takes in the user information, and then I used f strings just to dump in kind of age, generate exercises for person with this characteristics, all the user information, and then the keywords are below. So it says formatted as follows. And so GPT so far has done a very good job of formatting it exactly as I asked for it, and including all of these keywords in the output, which then brings us to formatting the output. I have those same keywords as a list, and I kind of iterate through the list, splitting on each one and taking the string that comes after the keyword but before the next keyword. And so I know that after name 1 is the name, and up until equipment needed 1, that is the name for exercise 1. And then after equipment needed 1, but before area of focus, that is the string that represents the equipment needed for exercise 1. And I kind of cycle through all of the keywords to get those variables and then strip off any extra white spaces or punctuation. So after all that, we get it up and running. The kind of key metrics we're looking for, like I mentioned, since this is a new application, there's no kind of time saving or business cost saving metric that we can turn to. It's more of a technical aspect of, does it pass all the component tests, do all those components for the login and the database and the hosting the function and the calls to the API, do they all work? And then string together all that for the end-to-end functionality. I also was looking to make sure that the cloud tools were updating as expected when a user creates an account. Does it actually create an account in the database? Does it create a document? When they save an exercise, does it save it to the right place? And then that the application is available at the hosted URL. So it's kind of just a lot of things to keep an eye on to make sure all the bills are getting paid and everything is talking to everything nicely. And then the way I kind of check the boxes for all the component tests was the test document, and we'll get into the specifics of that on the next slide. A bit of notional metrics for users, if we were launching this as a product, for example, would be primarily number of users signed up, number of exercises generated, kind of as a metric of engagement, number of exercises saved as a metric of kind of how well we're doing, how many exercises are actually meeting user needs. In that same vein, the percent of generated exercises saved. So if there's a high percentage of exercises generated being saved, that means we're kind of doing a good job in generating what the users are looking for since they're saving them, which would indicate that they're useful for them. And then similar to any other application, kind of monthly active users to see if we're retaining users, if we're adding value, if this is something that has any potential. So the component tests, I kind of broke them down into 4 sections. So the authentication, this is kind of in order of kind of how the user would interact with the application. So I won't go through all of them, but essentially you can create an account. You can't create multiple accounts to the same email. You can't log in if you don't get your credentials correct, things like that. You're able to log out. The front end is just the basic user UI. that you can add and delete your user information. You can generate exercises, you can save and delete exercises, and that everything populates when you log in. The database, like I mentioned, it's set. A document is created for each user. That document can be updated as the user changes their user information. Document is created for each saved exercise, and that correctly populates to the front end. If they delete an exercise, that document is deleted. Um, so fairly simple things in practice. It turned out to be a bit of a headache to make sure everything worked out correctly and was given a unique user or a unique document ID, and then kind of retrieving that document ID when you need to delete something. But so far, so good. And then the back end was all of the kind of communication between the JavaScript and the Python, and then the hosted Python functions talking to the OpenAI API. Um, and so getting I kind of broke that down into chunks of making sure I could figure out how JavaScript using a fetch request and post could send information to Python, kind of check that box, making sure the communication was there, then sent actual example user data, then broke it down into generating a prompt, filling in the prompt with the user data. Another section was just using the ChatGPT API, calling the API, using that prompt to call it, and then the big kind of chunk here was formatting the response. And I experimented with using things like regular expressions or trying to have ChatGPT output even more specifically formatted things, but it was a little bit inconsistent, so that's where I landed on the keywords to split on, and that seemed to work so far. Probably won't work every single time since ChatGPT's potentially not the most consistent thing, but it's worked every time so far. Fingers crossed. And then the communication back to JavaScript was actually a pretty big challenge. I think that is next in challenges. Yeah. Um, so I'll go through first in order. Kind of working with new coding languages was the biggest challenge. I hadn't used JavaScript or HTML much. Maybe 15 years ago, I tried to make an HTML website, but that was all gone. So I had to watch kind of incremental tutorials and a lot of tutorials looking at how to make an HTML page, how to add a button, how to add user input, how to add functionality to the button. Um, Same with JavaScript, how to add an event listener, how to add data to the HTML page when you retrieve it from a database, things like that, how to make those two talk to each other. The CSS file is just the styling overall. I didn't get too into the weeds for that. I kind of borrowed generic styling from one of the tutorials and that worked, and then figured out how to add that background image to the login page, and that was the extent of CSS. Um, and then Python I was fairly familiar with, same with the OpenAI API. So that was more figuring out the logic of getting the output and formatting it into variables. One of the biggest challenges in watching these tutorials was that Firebase, I think about 3 years ago, um, updated how their architecture worked. So it used to be a lot of Firebase dot this for methods, and it's turned into a different model that's they call the modular architecture. So you kind of create an instance of the database and then run methods on that. So there were a lot of tutorials that showed the old way, but that no longer worked with the new way. But there weren't as many tutorials showing how to use the new architecture. So there was a bit of mixing and matching of looking at how did somebody build this thing in Firebase 5 years ago, and then how am I supposed to implement that using the new approach. So it's a bit frustrating. It actually took me a while to figure out that there was a different approach. I couldn't understand why people were doing things so differently. But once I did, it made a little bit more sense. Um, Similarly, I got tons of CORS errors, which I didn't even know what that was before this, but it's cross-origin resource sharing, I believe, and that's just when browsers talk to each other to try to get data. So essentially, that fetch request, whenever something went wrong, you would get a CORS error, whether it was a security error or something didn't match up. And then I ran into that a lot when I hosted the Python functions because a number of different things caused the same CORS errors, and I could not figure out what was going on because there were, I think, three separate things causing the same error to pop up. The response didn't have headers. there was a method called options for some reason, I believe. That is when one browser kind of sends an initial message just to see if the message will work. Kind of like, in my mind, an authorization charge that a business might send to a bank just to make sure this communication is going to work. So I didn't have the options method headers. I didn't have headers on the response. I was just sending back the bare JSON dictionary. And then I mentioned earlier kind of the alignment between the version numbers of the packages and Python. I think there was an error, a mismatch there that was throwing an error that manifested as a CORS error. So essentially, if there was any error in the hosted function, it would show up as a CORS error. So I had to kind of work through three different solutions before I got it working, and I didn't know which one was causing the problem. In retrospect, I think all three was causing the problem, so it was a challenge, but we eventually got there. Um, the last couple I ran into just, I think last week or maybe 6 or 7 days ago. The app just suddenly stopped working. I was getting permissions errors that I had never gotten. I hadn't changed anything. Luckily, it was over a weekend. I logged back in on Monday and it just hadn't wasn't working. So I knew something out of my control had changed. It ended up being the test security rules that Firestore initially sets you up with only lasts for 30 days. It kind of gives everybody access to the database to make changes to develop while you're testing, and then it locks those down after 30 days, and that had expired. So I had to go back in and figure out how to extend that. Um, but it was a good lesson in kind of building in buffer time and expecting unexpected challenges. And then lastly, we already talked about the version and the library mismatch that threw a couple errors and was a bit of a headache, but we sorted that out eventually. And that is it for the overview. Hopefully that answers the mail. Hopefully we don't need this video at all since if the internet is working as expected. But I want to put this up just in case I had internet issues. And then happy to take any questions and then walk you through the app more if desired. Cheers. Appreciate it.